Hello everyone, welcome back to our third part in transformation in rigid motion, which is rotations. We have covered so far transformations and as translations, as reflection. Now we're going to discuss rotations in geometry. So our objective is to investigate the properties of rotation. And here comes an essential question: how do these properties affect on the congruence and the orientation of the figures? So far we have noticed that rigid motions, the size and the shape doesn't change. Okay, but what will happen to the orientation? What will happen to the congruency? So we have to take into consideration two things. In our rotation in this video, it's going to be a center of rotation around the origin, and we're going to study the rotation as counterclockwise 90 degrees, clockwise 90 degrees, counterclockwise 180 degrees, and clockwise 180 degrees. So we have four types of rotations we're going to cover in this video. Usually you have more, but we're going to specify on these as start. Now let's go for some vocabulary words. So we are going to use during this lesson. We are going to use rotation as a definition, which means that it turns about a fixed point. That fixed point is called the center of rotation. Okay, and at that center of rotation I will be having the angle measured, which is called the angle of rotation, which is affecting on the change of the position of the pre-image. Here I need to mention something very important. When I say a fixed point or center of rotation and the angle of rotation, how they are related to each other. So we said at the beginning of this video that it will be my origin is the center of rotation. So I'm going to consider this is my center. I'm going to call it O. Okay, and I have an image that is called A, point A. I'm going to take a rotation as a counterclockwise, anti-clockwise. Okay, when I take anti-clockwise of rotation as 90 degrees, so A, okay, will go up 90 degrees till an opening and will be located as an A prime. Now between the distance OA will be equal to OA prime. These are two important points that when I have rotation, I have same distance and I have the angle of rotation. Okay, which is I have an angle 90 degrees. So the image connected to the center of rotation and center of rotation connected to the pre-image, I will obtain an angle of 90 degrees, which is I described it at the beginning. This center of rotation is the same as the angle of rotation. And as you have seen, we have a counterclockwise and we have clockwise. As I said before, counterclockwise is anti-clockwise. It rotates opposite of a clockwise or the clocks that we wear. Let's identify this rotation. Now through the examples we have to understand this lesson. So as we need to identify here the rotation, as you have noticed that O is my origin. Okay, so from A to O, from my pre-image to O, is the same as from my origin to the image. So I have to connect A to O, and then I have to take the same distance forming 90 degrees and complete the angle to get my new location A prime. The same thing applies on B, on C. Let's take C for example. Okay, this is C. Okay, if I need to take C to O, I'll take the same distance and create 90 degrees at O. So I will get my figure that I need. So this is 90 degrees. Now what do you notice in this figure? You notice that CO is equal to OC prime, right? As I have said before. Okay. If I'm moving with the same distance, what can I say about the triangles ABC and A prime B prime C prime? So I have triangle ABC and triangle A prime B prime and C prime. If you have noticed between this the length of each, I will find that AB is equal to AB prime, A prime B prime. BC is equal to BC, B prime, C prime. AC is equal to A prime, C prime. So these two triangles are congruent. And I'm sure that the angles are going, the angles are going to be congruent as well. Now, if I need to describe this rotation, so we have noticed that the triangles are congruent, where the sides are all congruent. Okay, now I'm gonna talk about describing this rotation. So if I need to describe this rotation, okay, it will be counterclockwise, because it's going the opposite of a clockwise. Okay, and it will be 90 degrees around. I have to mention my center of rotation around the origin. So this is how I describe my rotation. Now, if you have noticed here, what happened to the position of the triangle? Is it the same position or a different position? What happened to the orientation of these two, of my pre-image ABC? Let's go for the example. I need to identify this rotation. The same thing I will do. I have K, here it's not mentioned properly, I'm gonna mention it. This is my K prime. Okay, this is my M prime, and this is my L. So I need to identify the rotation. It means I need to say whether it's counterclockwise or clockwise. And as you have seen in the figure, it is counterclockwise because it's moving from here to there, from first quadrant to the third quadrant. So since it's moving from the first quadrant to the second quadrant to the third quadrant, I'm sorry, so it is counterclockwise. Okay. Now, if I need now to identify my angle, I'm going to join K to K prime through O, because as we said and we have discussed before, that O is my center of rotation, considering in all our slides. So what do you notice? It forms a straight angle. This straight angle, when I have a straight angle, it will be called 180 degrees. So it is going to be counterclockwise around 180 degrees around the origin. This is what we need to mention every time. The same thing applies to L and L prime. Let's join L and L prime. What do you notice? This is L to O and O to L prime. It is the same distance and they form in what? 180 degrees. Let's take M to N prime. The same thing goes for M to M prime. I have 180 degrees formed. Let's take, these are the 4 cases I have discussed before. We're gonna discuss how to rotate a figure clockwise around the origin. As you have noticed, we take a point B to the origin. Okay, and then we're gonna take the same distance forming 90 degrees and we're gonna call it B prime. The same thing will be for C, and for A we're gonna do the same thing. We're gonna take from O to C, and then forming a 90 degrees, we're gonna go for O to C prime with the same distance we have from O to C, O to C prime, and we're gonna obtain this triangle A prime, B prime, C prime. Do you notice how the A is not still, it's in a different location, and it is clockwise, so of course I have to go into this direction. And if you notice that A prime C prime is 3 units, AC is 3, BC is 2 units, BC it's still U. So if you need to use Pythagorean theorem, you will find the length of AB would be equal to A prime, B prime. Going for the second one. Now rotating also clockwise 180 degrees. You have to take the same distance. As we said, we have to draw a straight line. Since I'm saying 180 degrees, when I say 180 degrees, it means I am discussing straight angle. Straight angle. Okay? This is what I need to take into consideration when I'm talking about 180 degrees. So this is an easy one. You draw a straight line through the origin with the same distance, and you will get your result for triangle, for the rectangle A prime, B prime, C prime, D prime. Okay, and then you have the 90 degrees now counterclockwise. We're discussing counterclockwise, so I do the same thing. I have to draw from A to the origin and forming 90 degrees angle, and I plot the point for each one. So the same thing I need to do from D to D prime, from C to C prime, from B to B prime. So you need to take into consideration each point on the figure given. Let's go for our last example. We need to rotate a figure 180 degrees counterclockwise around the origin. And you have noticed here again, so it is 180 degrees, so I'm talking about a straight angle from A prime. So I have 3 straight angles I should draw. So I'm going to join O to A, and I'm going to complete it, my angle, to form a straight one and plot A prime. I cannot plot A prime anywhere, no, it should be AOA equals to OA prime. The same thing I should be doing for B and for C. So I will obtain these ones. Let's show you how. B, if you take B to O, okay, I'll stop here, then I'll think, okay, so from B to O I have to go up the same distance. Since it is, I have it as 1, -4, I have to go for the, I know that I'm moving from my fourth quadrant to my second quadrant, so it is because it's, so it is going to be counterclockwise. Okay, so I have to complete it as a straight angle, and it will be B prime here. The same thing goes for C prime, C and C prime. So I'm gonna join them, and this is C to C prime. That's it for now. Kindly watch out while you are drawing, that you have to obtain the same distance, as I said, from the pre-image to the center of rotation, and from the center of rotation to my image, and that center of rotation is my reflection. We have discussed, I think, about the congruency. How does it affect rotation on the congruency of the triangle of the two figures? But what about the orientation? That's a question I'm going to leave it to you to think about. Thank you.